Assalamu alaikum. And after a long time, we are having a class. What will we do today? As usual, revision. And after that, we'll see the last topic of chapter number 3, the electronic configuration. So, chapter number 3, comparatively an easier chapter. If you compare it with chapter number 2, that was the difficult one, and it still needs a lot of work to do in that particular chapter. This chapter is theoretical. You don't need so much mathematical or no numericals, no problems like this, etc., etc. Everything is so simple written, okay? Only the theories are there, so most of the students like this chapter a lot. Let me recall the topics. The name of the chapter is the atomic structure, and we went through the different theories like Dalton's atomic theory, like modern atomic theory, then the discovery of electron, in discharge tube experiment, discovery of proton, radioactivity, fundamental particles, all right, Rutherford experiment, and then after Rutherford experiment, Bohr's, and then these definitions, atomic number and mass number. All right, let's start the revision properly. Atomic number. Those of you who have done the assignment, salute to them. That's good. You still have today's time till 11:59. You can submit the assignment. If you have any question regarding completing it, you can ask. I told you that this assignment number 2 is you can consider it as a real assignment. You will have to do a lot of effort to find out the answers. It's a practice sheet. All right. So what is the atomic number? Number of protons present in the nucleus of an atom is called atomic number. It is represented by Z. What else? Mass number. If you add protons and neutrons, here comes the number. That number is called mass number. All right. If you see two numbers written with a symbol of an element, then the smaller number always represent what? The mass number. Or smaller number always represent, I'm sorry, the atomic number, and the bigger number always represent was the mass number. As you can see over here, nitrogen is the symbol of nitrogen. Two numbers are written 7 and 14, then the smaller number represents atomic number, and the bigger number represent what? The mass number. Atomic number, proton number, electron number, all are same all the time in a neutral atom. Neutral atom means when there isn't any charge. When you don't see any charge on an atom, it means it is neutral. In this condition, no charge. In this condition, proton, electron, atomic number, all three would be equal. Okay? And how can you find number of neutrons? Just subtract the smaller number from the bigger one. Then another topic we have done, isotopes. Isotopes of the same element. Isotopes means atoms of the same element having same atomic number but different mass number. Means, for example, carbon. So there are the carbons which differ in their masses. For example, we have carbon 12, we may have carbon 13, we may have carbon 14. So all of these are carbons. Why? Because their atomic number, proton number is same, but their mass number is different. Why? We have seen earlier, it is due to the difference in number of neutrons. Like in carbon 12, there are 6 neutrons. In carbon 13, there are 7 neutrons. In carbon 14, there are 8 neutrons. It's revision. Again, I'm talking to those who have already paid attention on these topics, not explaining the topic right now. Bohr's atomic theory. According to Mr. Bohr, electrons revolve around the nucleus in various orbits, having fixed energy. called energy levels or shells. As you can see on the screen, electrons in atoms can move only in certain specific orbit called energy levels or shells. As you can see on the screen right side, the very first shell is the smallest one. Its name is K shell, then L shell, M shell, N, O, P. These are the various shells. Okay, just visualize over here, sun and different planets are revolving around it in their orbits, like Jupiter, Mars, Earth, etc., Pluto. All are revolving in their orbits. Similarly, electrons are revolving around the nucleus if they are there in different orbits. We call these orbits as energy levels or shells. We name them. What is the name of the first one? K shell, L shell, M, N. All right. So that is, you can see on the screen, these shells are designated as K, L, M, N, O, and P, represented by 1, 2, 3, and 4, 5, 6 numerically. What does it mean numerically? If I ask, what is the numerical value of L shell? You say, L is the second shell, so second means 2. If I ask, what is the value, what is the number of M? You say K, L, M, third shell. If I ask, tell me the number of first shell, K shell, 1. Okay, so each shell has designated symbols K, L, M, and O, P, which are represented mathematically by 1, 2, 3, 4, 5, and 6, as you can see on the screen also. All right. Now the capacity of each shell is fixed, right? For example, K shell is the smallest one. Its capacity is low. It can just accommodate 2 electrons. L shell is little bit bigger. It can accommodate more electrons than the K shell, 8 electrons. Okay? M shell even greater, bigger in size, can accommodate more, 18. Number 4 shell, 32, 50. So, what is the point here? The capacity of each shell is fixed. And how can we find the capacity of a shell? We'll do some board work. All right? So, just check out your notebooks. So, chemistry. Grade 9. What is the topic over here? Electronic configuration. What is the point here? That the capacity of each shell is fixed. And how can we find out their capacity? Here's the formula. The capacity of a shell can be calculated by 2n square. What is n? Where n is the shell number. It's so simple. All right. So you have seen on the screen, I'm just drawing it over here. Nucleus. This is nucleus. First shell, its name is K. L shell, M, N, etc. We are willing to find out the capacity. Capacity means how many electrons can be put to the maximum extent in a shell. For example, if I want to find out maximum number of electrons in third shell. So question, third shell. What is the name of the third shell? KLM. It means I am willing to find out the capacity of M shell. So what is the value of N over here? 3. What is the value of N over here? 3. M shell, third shell. We are willing to find out the capacity in it. So we will write the formula 2n square. What is the value of N over here? 3. What is the square of 3? 3 square means 3 into 3. Let me write it, okay? I'm showing some extra step, you can skip them. So what is the answer? 18. It means third shell can hold maximum 18 electrons, not more than that. Not more than 18 electrons third one can hold. All right? See, again, I'm willing to find out the maximum electron in third shell. This is my question. So I wrote here n is equal to 3 because what is the value of M? M shell is third shell. Let me write over here. K shell is the first one. You can see over here. L shell is the second one. M shell is the third one. N shell is the fourth one. And O shell is the fifth one. And so on. All right? So I think most of you have understood what have I done over here. Okay. Now I will start from the beginning. K shell. K shell means first shell. So here the value of n is 1. I write here 2n square. Intelligent students, what is the square of 1? 1 square means 1 into 1. Okay, I'm writing it directly. So first shell can hold how many electrons? Just 2 electrons. How many electrons it can hold? Just 2 electrons. All right? Okay. L shell. Can you do it by yourself? Try. Don't see, don't look at the board. Try by yourself. I am solving here on the board. You can verify it afterwards. If you have done, just a WhatsApp its picture that you have done the question right now within 30 seconds. नेक्स्ट क्लास यहीं पे लेना. I hope you have understood. It's so simple. All right. So what is the capacity of first shell? 2 electrons. It can hold just 2 electrons, not more than this. What is the capacity of L shell? 8 electrons. What is the capacity of third shell? 18. I'm sorry, I should write over here N shell is the fourth one, and 32. What is the capacity of fifth one? Quick. Correct. 5 square, 25. 25 to the 50. So what is the capacity of the next one? 50 electron. That's good. Okay? I'm going to erase it. All right? Erasing it after 10 seconds. All right. So, I'm writing here just for myself, shell and its capacity. I'm writing it for myself. K shell can hold just 2 electrons. L shell can hold just 8 electrons. M shell can hold just 18 electrons. N shell can hold just 32 electrons. O shell can hold just 50 electrons, and so on. All right? Okay. Question. Right. Before I proceed, what kind of question you expect from the previous topic that we have just finished, blanks? For example, it's written the maximum number of electrons that M shell can hold is dash. Just write the answer. Second shell can hold dash number of electrons. That's right the answer. Okay. Now the question is, write the electronic configuration of sodium. I have written here sodium with 11. So 11 is its atomic number. So we have 3 predictions over here. 11 electrons, 11 protons, 11 is the atomic number. So if you see a number over here, it means it has 11 electrons. Number of electrons in sodium is 11. Right, thank you. Is 11. Okay? So, Out of 11 electrons, now we are arranging these electrons in different shells. See, nucleus. Out of 11 electrons, how many could accommodate in the first one? In the first shell, how many electrons you can accommodate? Just 2. So K is holding how many electrons? 2 electrons. Out of 11, 2 are in the first shell. How many are left? Out of 11, suppose there are 11 guests, 2 are here. How many are left now? 9. They will accommodate in the next room. Which is the next room? L shell. How many it can hold? 8. 1, 2, 3, 4, 5, 6, 7, 8. So out of 11 electrons, 11 guests, 2 are in the first room, K shell, 8 are in the second room, the L shell. So how many electrons are there in the second one? 8. So out of 11 electrons, 10 have been allocated their positions. How many are left? 2 plus 8, 10. Just 1 is left. Where will the last guest, where will the last electron will go? Obviously in the last one. This is called the electronic configuration of sodium. Okay? Second one. Write the electronic configuration of sulfur 16. Number of electrons 16. Out of 16, how many in the first shell? Just 2. How many in the second one? 2 plus 8, 10. How many are left? 2 plus 8, 10, 16. 6 are left. So 6 will go in the last one. When you add these superscript, this should be equal to this number. What should you remember? Whatever you write here should not exceed with these values. I wrote here 2. I wrote here 8. M can hold maximum how many electrons? 18. If it's not there 18, it's 6. Okay. Should not be greater than that particular value. All right. Similarly, if I say hydrogen, I will be a little bit quicker. You can write like this, or you can also write like this. K is equal to 2 electrons, L is equal to 8 electrons, M is equal to whatever, 6 electrons. You can write either in this way or in this way. Both are same. So what is in our syllabus to find out, to write the electronic configuration of first 20 elements is there in the book. This is the same assignment. Hydrogen 1, so 1 electron is there. So what it will be? K1. Next is helium. How many electrons it has? 2 electrons. K2. Lithium 3. It has 3 electrons. So it will be K2 L1. Similarly, you will do for first 20 elements. So what will you do at your home? Write the electronic configuration of first 20 elements and submit in the Google via the Google Classroom. All right. Exercise chapter number 3. Thank you so much. Take care.